Hey guys, welcome to the question 1 walkthrough for the today's physics test. Okay, so I already have a pre-drawn diagram of I forgot his name, but let's just call him John. Okay, we're gonna call this person John. Okay, so we have drawn the ski trip for John. Okay, so he goes down the slope, he goes back up a ramp, and then he begins the projectile motion, and then he lands back on the ground. Okay, so the first question it asks you, it's basically, alright, so what is the EP? What is the EP of John? Okay, we'll just call this person John. I forgot what his name was, but we'll just call him John for now, okay? What is the EP of John relative to the lowest point of the ski? I forgot the wording, but so just say ski ramp. Okay, so John is 75 meters above the ground. Okay, so obviously you can see that here this is the lowest platform of the ski ramp. Okay, so therefore the vertical height is 75 meters and John weighs 78 kilograms. Okay, 78 kilograms, and it wants us to find the EP. Okay, so basically you can just say EP equals to mgh. Okay, so therefore you can plug in EP equals to mass is 78 multiplied by 9.8 multiplied by the height, which is 75. Okay, you can plug this into your calculator. Okay, plugging this into your calculator, so you plug this into your calculator, you should be getting I should get EP equals to 57,330 joules. Okay, so that's your gravitational potential energy here, and this should only be just an achieved question here. Okay, this is achieved. Alright, moving on. Question 2. Show that the speed of John, not the speed, the velocity, sorry, of John is 31 meters per second when he begins projectile motion. Okay. Show that the velocity of John is 31 meters per second when he begins projectile motion. Okay. So now in this question we need to do a little bit of the energy conservation theory. So we're going to be assuming that the EP is converted to EK. Okay. So as you can see, so when John falls, okay, he's going to fall a total of 75 meters. So he falls from here to here. Okay, that's 75 meters downwards. Okay, he falls. Okay. So, but the thing you have to notice is that he has to travel back up this ramp here. Okay, he has to travel back up the ramp before he begins the projectile motion. Okay, and you see the top of the ramp is 25 meters above the ground. Okay, so therefore John goes down 75 meters and he comes back up 25 meters. Okay, so therefore from the starting point which is here and getting up to the top of the ramp, he went down a total of 50 meters. Okay, so he went down a total of 50 meters. Okay, so that's what we're going to use in our calculation. Okay, so we're going to say John travels 75 meters down, but then 25 meters up. Okay, 50 meters down total. So now we can say that John's EP, so EP lost equals EK gained. Okay, so EP equals to, okay, so you have 50 here, so basically 78, not 78, oh yeah, it is 78, so 78 times 9.8 times 50. If you plug this into a calculator, you should be getting times by 50, that's a 0 here, so times by 50, that should give you EP gives you EP equals to 38,220 joules. Okay, so he loses So he loses 38,220 joules, and that amount of energy is converted into EK. Okay, so now we're gonna say EP equals to EK. So therefore, 38,220 equals to half mv squared. Okay, plug in the numbers you know. So it's 38,220 equals to half mass. John's mass is 78 multiplied by v squared. We don't know. We're trying to find the velocity. You move the 1/2 to the other side, it becomes multiplied by 2, okay? So basically, 38,220 multiplied by 2. You move the 78, so you multiply 78 on one side, so you divide on the other, okay? So you're going to say divided by 78, and that equals to v squared, okay? But we don't want v squared, we want v, okay? So we're going to square root the whole thing, and that should give us the v, okay? And if you plug this into your calculator, so if you do everything, so square root, if you square root, you should be getting 31.3 meters per second. So velocity equals to 31.3 meters per second, and that rounds down, so you can say rounds down to 31 meters per second, okay? So it says rounds down to 31 meters per second, okay? You'll say that that's in 2SF, okay? Okay, I'm pretty sure, I don't have the mark schedule with me for this question, okay, so I'm not too sure what this question is, okay, but I'm relatively, so I'm about 80 to 90% sure that this is a merit question, okay, so getting all the way up to here, okay, that will get you a merit grade, okay, and in terms of achieved, what I'm thinking about achieved is finding the EP lost, okay, I'm pretty sure finding up to the EP lost will get you an achieved, okay, alright. Next question, okay, so I'm just gonna rub these questions off, okay, so don't forget to pause the video if you need to see what I've written, but I'm just gonna rub everything off, okay, because I want the diagram to be here so I can explain easier. So I'm just gonna, sorry about this is tedious. Okay, question 3, okay, so what does question 3 ask us? Question number 3 asks us to find the vertical velocity, so vertical velocity equals to we don't know, and then horizontal velocity equals to we don't know either, okay? So you can see that you can see here, so the initial velocity is 31 meters per second, and it makes an angle of 32 degrees with the horizontal, okay? So by using with our knowledge of the right angle triangles and using our knowledge of the SOHCAHTOA, we can find the vertical velocity and the horizontal velocity, okay? So if I draw the diagram out here, make it a bit clearer, okay? So it should be 31 meters per second, so 31 meters per second. So now we have 32 degrees, and we have our horizontal component here, okay, and we have the vertical component here, okay. So as you can see, this is hypotenuse side, opposite the angle, so opposite side is here and adjacent side is here, okay. So you can see that, okay, let's try to find the vertical velocity first, okay. So as you see, the vertical velocity is opposite the 32 degrees, and we also have the hypotenuse. So we have both O and H, okay. So therefore we're going to use SOL, so SOL is sine, okay, so we're going to use the sine rule, okay. We're going to say sine 32 equals to O over H. Therefore, sine 32 is equal to O, which is VV, vertical velocity, divided by 31, okay. You plug this into your calculator. Don't forget that your calculator should be in the degree settings, okay? So you say sine 32 multiplied by 31, and that should give you V vertical velocity equals to 16.43 meters per second, okay? So that's your vertical velocity found, okay? Now you need to find the horizontal velocity, okay? So as you can see here, so horizontal component is the adjacent side, and we also have the hypotenuse side, which is 31 meters per second, okay? So now we have A and H, okay? So we're going to be using the car rule, okay? So we're going to use the cos rule, okay? We're going to say cos 32 equals to A over H. Therefore, cos 32 equals to, adjacent is, what am I doing? Adjacent is the horizontal component, and that divided by 31. So therefore, cos 32 times by 31 should give us our horizontal component. And if we plug this into our calculator, gives us the horizontal component is equal to 26.29 meters per second, okay? So you found, so if you get to be able to find both of these horizontal and vertical component, it's either a merit grade or an achieved grade, okay? I'm not too sure which one it is. If I had to say a grade, it could be a merit grade, okay? I'm guessing that this could be a merit grade, but I wouldn't bank my thoughts on it, okay? So I'll just say this is an achieved question for now, okay? With the possibility, so M possible, okay? I'm not too sure. I don't have the mark schedule for this question, okay? But it's definitely at least an achieved question, okay? That's what I know for sure. Alright, so I'm just gonna move on. I think this the last question, okay? The last question was asking you to find the horizontal range, okay? Horizontal range traveled from when he starts the projectile motion, okay? So basically, as they say, I labeled it here, so this is what they want you to find, this horizontal range here. Okay, so how do I approach this question, okay? So, like most of the projectile motion questions in class, right? It's mainly covered when the ball or the object starts from the ground, okay? But the problem here is that the ball or thing doesn't start from the ground, okay? So you can cut the problem in half, right? So basically, in terms of time, this is not symmetrical, okay? Not symmetrical. Okay, why is this not symmetrical? Because on one side, it starts 25 meters upwards, on the other side, it lands all the way at the ground, okay? So therefore, you cannot find the time to max height and then multiply by 2 to find the total time, okay? You can't simply multiply by 2 in this case, okay? And this time, you have to manually work out how long it takes from the max height to the ground. It's more harder because you have to manually do it, okay? Because you cannot assume it's symmetrical, okay? So how do you approach this question, okay? So we found our vertical velocity and we also found our horizontal velocity, okay? So what do we do now? So what do you want to find? Okay, you want to find the horizontal range, and you know that the range is equal to horizontal distance is equal to, we know it's horizontal velocity times by total time, okay? We already have our horizontal component, okay? But what we don't have is the total time, okay? So you should make it your goal. So your goal of the question is to find the total time, okay? So when you found the total time, you've basically got your answer, okay? So what is the total time? So we gotta work here, okay? So as you can see, the ball, okay, not the ball, I keep saying the ball. So John, okay? John is starts with a vertical velocity of 16.43 meters per second, okay? And he starts 25 meters above the ground, okay? So we're going to calculate how long it will take for John from the starting point to the max height, which is here. So how long will it take for this vertical velocity to become 0 due to the influence of gravity, okay? So this is pretty familiar, okay? So we're going to use the VF equals to VI plus AT equation, okay? VF at the max height, so the vertical velocity at the max height is always 0. So 0 equals to VI equals to 16.47. Okay, because gravity acts in the opposite direction as the velocity, so it's minus 9.8 t. If you rearrange this equation, you'll get t equals to 16.47 divided by 9.8. Okay, so now you can plug this into your calculator. So 16.47 divided by 9.8. Okay, we get 1.68 seconds. So t equals to 1.68 seconds. Okay, so we found how long it takes to reach the maximum height, okay? So the next step, you might be thinking, oh, we should just multiply this by 2 and we'll find our total time, right? No, wrong, okay? That's big no, big no. So like I was saying before, the parabola is not symmetrical, okay? Because on one side, you're starting 25 meters up, and on one side, you're going all the way down to the ground. It's not the same, okay? So if I cut this in half, you'll see that the parabolas are different, okay? It's not the same. You cannot just multiply by 2. It's called, you have to work it out manually, okay? So remember, it's a big no-no. Don't do that, okay? Don't do that unless the parabola is symmetrical. So as long as it starts at the same point and ends at the same point, okay? That's the only time when you can multiply t by 2. Okay, so you're thinking, oh, okay, so I'll just find out the time it takes for the ball to reach the ground then. That's cool. So what do we have? So we have, in terms of starting at the max height and going down to the ground, so what do we have? So at the start, at the maximum height, the vertical velocity is 0, so vi equals to 0 meters per second. We also know that gravity, so acceleration, is 9.8 meters per second. It's positive because they're acting both in the same direction, okay? What else do we know? I'm trying to find t. We don't know t. But as you can see here, we only have 2 variables, but we need 3. But we need to have 3 out of 4 in order to find our missing variable. So right now, it's impossible, okay? We don't have enough information to go off, okay? Oh, one thing you can do is you can find the what is the maximum height. So how high is John up from the ground when he is at the maximum height? That's a good idea. Maybe we should do that first. Okay. So what we want to do now, okay? We want to find distance at max height. Vertical distance, I should add vertical distance at max height, okay? So you would approach this the same way you would do for a normal question, except one thing you have to remember, that he starts 25 meters above the ground. So at the end, you're going to add 25 meters onto whatever result you get, okay? So basically, you know it takes 1.68 seconds for John to reach the maximum height. So we know t equals to 1.68 seconds. We know that the initial velocity is 16.47 meters per second. The final velocity, which is at the max height, is 0. So Vf equals to 0 meters per second, okay? And we're trying to find d. So d equals we don't know, okay? So we can so the easiest equation to use here is d equals to vi plus vf divided by 2 multiplied by time, okay? If we plug our numbers in, so we say d equals to initial velocity 16.47 plus final velocity, which is 0, divided by 2 multiplied by our time, which is 1.68, okay? So we plug this into our calculator, so plugging this into our calculator, so 16.47 divided by 2 multiplied by our time, which is 1.68. That should give us 13.8 meters, so d equals to 13.8 meters, okay? So from the starting point to the max height, he travels 13.8 meters, but we have to remember that he starts 25 meters above the air. So you have to add an extra 25 meters. So you're gonna say, what am I doing? So you're gonna say 13.8 plus 25 equals max height. So therefore, this equals to, if you plug this into our calculator, 13.8 plus 25. That gives us 38.8 meters. So 38.8 meters. So that's your distance, okay? That is how high the ball, not the ball. Why do I keep saying ball? That's how high John is above the air, okay, at the maximum height. Okay, so that's the max height we found, okay? So now the next step, we don't have enough space. I'll do it on another page. Okay, so now we have our max height, we have our time, we have our initial velocity, and we need to find how long it takes, okay? So let's list down everything we know. So let's just draw the parabola here, okay? So forgive me, so let's just draw the parabola here, okay? It doesn't really look like that, it looks more like, okay, so it looks more like that, okay? So now we have the max, so we have distance at max height, time at max height, and we're trying to find how long will it take to reach the ground, okay? So basically, from the max height to the ground, so the initial velocity is 0 meters per second, because at the max height, the vertical velocity is 0. We have our acceleration, that's positive 9.8 meters per second, but now we also figured out the distance. We figured out that the vertical distance is 38.8 meters. And now we have to find time. So how long will it take having acceleration and having an initial velocity will it take to cover a distance of 38.8 meters. So what equation can you use? So the best thing to do here is looking at your kinematic equations. So what involves all 4 of these? Okay, so you can see that it should see that which one was it should be d equals to vit plus half at squared. Okay, so now we just substitute our numbers in. Okay, we'll just substitute d equals to 38.8. Well, we substitute that vi equals to 0, so anything times 0 is still 0, so 0 times any time is still 0, so we're going to say 0 plus half of 9.8, half of 9.8 multiplied by t squared, Okay, so now we're going to rearrange the equation to find for t. Okay, so if you move the 1/2, so if you multiply by 1/2 on one end, you have to multiply by 2. So if you multiply by half on one end, you'll have to multiply by 2 on the other end. Okay, so it becomes 38.8 times 2. Okay, if we times by 9.8 on one side, we'll have to divide by 9.8 on the other side, and that will equal to t squared. Okay, so now we just square root the entire thing and we'll find t. So 38.8 times 2 divided by 9.8 square root equals t. You plug this into a calculator, so 38.8 times 2 divided by 9.8 and square root of answer. And that should give us 2.81. So t equals to 2.81 seconds. So that's great. We found out the time it takes for the ball to we found out how long it takes for the ball from the max height to reach the ground. Okay, so the total flight time. So what is the total flight time? The total flight time is how long it takes for the ball to reach the maximum height plus how long it takes for the ball to go from the maximum height to the ground. Okay, so I think what was the number again? The time to max height. Yeah, 1.68 seconds. Okay. So basically, total time we can say is, so total time equals to 1.68 plus 2.18. So 1.68 plus 2.18. That should give you, that's wrong, not 18, it's 81. Got it the wrong way around. Sorry about that. 1.68 plus 2.81, that, oh gosh, this calculator is broken. 1.68 plus 2.81, that gives us time equals to 4.49 seconds. That's great. So now we have our total time and we have our horizontal component of the velocity. Okay, so now we can substitute these numbers in and we can find the horizontal range traveled. Okay, so basically we know our VH equals to 26.29 meters per second, and we know our total time is 4.49 seconds. So range equals to 26.29 multiplied by 4.49, and that's the horizontal distance traveled by John. 4.49 multiplied by 26.29, that should give you 118.04. So range equals to 118 meters, 0.04 meters. So John travels 118 meters, 0.04 when he begins the projectile motion, and when he lands on the ground, he travels a total of 118.04 meters. And that's your final answer here, okay? So getting all the way up to here, 118.04 meters will get you, I'm 95% sure this is an excellence question, okay? We'll probably get you an excellence question, okay? In terms of getting a merit, yeah, I'm not too sure. I'm just gonna skip that for now, okay? So, because I'm not too sure what it takes to get a merit and what it takes to get an achieve. But if you get the final answer with all the working, you'll get an excellence grade, okay? Alright, so that's basically it for question 1, okay? I hope you enjoyed the video, and if you have any questions, don't hesitate to leave it in the comments below, okay? Thank you for watching the video. Thank you.